Today we're working on section 3.3, which is solving systems by substitution. So in our previous sections, we solved systems by graphing. We graphed the lines for the equations, and we found the one solution that they shared, which was an ordered pair, x comma y, where there's those two lines crossed one another. One other method that we can use to solve the system is called substitution. We've technically done this in the past. We also did it on the worksheet yesterday. We are substituting a value in place of a letter. Since y is that, we're replacing y with that number and finishing solving. So when we do this, 56 equals 11x minus 10. And we can finish solving this equation for x. To solve, we're going to add 10 to both sides. We're left with 66 equals 11x. To get x alone, we have to divide by 11. So 6 equals x. Because x is 6 and y is 56, that is the ordered pair 6 comma 56. We can technically substitute more than just a single number. We can substitute an expression from one equation into the other. It's mostly used when you have y equals an expression or x equals an expression, and then you can substitute it into the other. Remember, we want to write our answer as an ordered pair, which is x comma y. So we're going to solve these using the substitution method. Might be helpful if you have a highlighter. So looking at number 1, in these two equations, we have y alone already in the top one. So we can substitute y with 3x plus 2. When we do that, though, we have to use parentheses. So we have x plus 2, and in place of y, so again, all I did was put those parentheses, but in this place, we are going to put our 3x minus 2 in that spot. I'll just write it again and fill in this next step. So we have 3x plus 2 going in this spot. Okay, again, because y was alone, we are substituting what y is equal to in place of y in the other equation. Now, this is like solving any equation that has the distributive property and combining like terms. Our next step is to multiply 2 to each. So we have x plus 6x, because 2 times 3x is 6x, and then 2 times 2 is 4, equals 11. We can combine like terms. Remember, this is like a 1x. 1x plus 6x is 7x plus 4 equals 11. To finish solving for x, we're going to subtract 4 from both sides. We're left with 7x. Oops, I crossed out the wrong one, sorry. 4 minus 4 cancels. We're left with 7x equals 7, or almost done to find x. Divide both sides by 7. So x equals 1. But we're not quite done yet. We need x and y to have our solution. Once we find x, we need to then go ahead and plug back in so y equals 3 times x plus 2. We found that x was 1, so 3 times 1 plus 2. Y is equal to 3 plus 2. So y is 5. Our final answer for number 1 is 1, 5. So the steps that we took, we got x or y alone. In this case, it was already alone at the top. We substituted into the other equation for x or y. We simplified that expression and combined like terms. That's how we got to here. We finished solving for x. So again, we started with the piece that was being added or subtracted to get rid of it. And then we had to divide to get x alone. Then plug back in to solve for the other letter. Let's try this again for number 2. So here we could either substitute in for x or y. Doesn't matter which one. So let's do this. Let's substitute for x in our other equation. So y equals x minus 2. And we're putting the expression for x in those parentheses. So y equals the expression for x, which is 17, minus 4y, and then we have that minus 2. Here, there's nothing to distribute, so we can simply combine like terms. So 17 minus 4y minus 2, we can combine the 17 and the minus 2. (15 minus 4y). You'll notice we have a y on the left-hand side and the right-hand side, so let's get them on the same side. Let's add 4y to get the y's on the same side. Remember, when nothing's written in front of that y, it's like a 1y. This becomes 5y equals 15. To get y alone, separate the 5 from the y, so we divide by 5. So y equals 3. So this is just one of our letters. We're going to go ahead and plug it back in. When we do that, we have x equals 17 minus 4 times y. In that spot, we're plugging in 3. X equals 17 minus 12. Remember, we have to do multiplication first before we can do addition or subtraction. So x is equal to 5. Our final answer as an ordered pair, x comma y, so that's 5 comma 3. It's a lot of steps, but it's taking everything we learned in the first chapter and some things from the second to be able to solve these. Now, what if we don't have a letter already on its own? We have to rewrite. My suggestion is to get the letter by itself that doesn't have a number in front. So here, that x doesn't have a number in front of it, so this one would be easier to rearrange. If I start with x minus 2y equals negative 6, to get x alone, I'd have to add 2y to both sides. So I'd be left with x equals negative 6 plus 2y. Now that x is alone, I can substitute that expression in for x here. So we've got 4x plus 6y equals 4. Remember, we're substituting for x, so that's going to go right in here. So 4x plus 6y equals 4. So here, I'm putting negative 6 plus 2y in that spot. Distribute, which means multiply. Negative 24 plus 8y plus 6y equals 4. Combine like terms. Negative 24 plus 14y equals 4. To get y alone, we're going to remove this negative 24 by adding 24 to the other side. Since neither one of them have any variables, we can combine them together. So we're left with a positive 14y equals 28. To separate the 14 from the y, divide by 14. So y equals 2. Now that we have y, plug it back in. To solve for x. X equals -6 plus 2y. In that spot, we're plugging in 2. X equals -6 plus 4. So x equals -2. Writing it as an ordered pair. -2, comma 2. I want you to go ahead and try 4 and 5. We're going to skip 6. Try 4 and 5. Oops. Okay, solution for this one is 2 comma 1. All right, number 5. Okay, now that we've got x, plug it back in to solve for y. And again, that -2 is going right in there. Just so happens that this ordered pair -2, -2. And then we're going to skip number 6. Hopefully that makes sense. The more you practice, the easier this process will become.